Hello everyone. This is the Lighten Up research team's final presentation for our CGT 412 Senior Capstone project. My name is Spencer Hale and I'll be introducing our team's research study. I will go over our research goals, measures of success, team roles, and methodology. I will then present our results, analysis, and conclusion. The other members of the team are Andrew Culbertson, Finley Simon, Gabriel Porter, and Lauren McDaniel. We started this project by thinking about different lighting techniques for 3D environments, especially in using lighting to create emotional atmospheres. In brainstorming, we realized that there are actually very few 3D CG animated horror films, and further, that most of the visual horror in these films is physical horror, such as monsters or gore, rather than psychological horror created by the environment and atmosphere. From these factors, and from academic research, we drew the conclusion that there is a distinct absence of techniques for creating a horror atmosphere through object and environment lighting in 3D CG animation. So the goal of our research was to test 3 different environmental and object lighting techniques, which we determined through preliminary research in identifying whether there are significant differences in perceptions of horror with different lighting techniques. In order to accomplish the aforementioned goal, we determined the necessary steps needed to reach it. These steps were as follows: choosing 3 different lighting techniques to test, drafting a brief overview of the survey and assets we wanted to create, determining our measures of success, and delegating the tasks. The following 4 slides will go into detail about each of these tasks. As mentioned prior, we chose our lighting techniques based on the preliminary research we investigated. Preliminary research showed the following 3 techniques being some of, if not the most, common for horror lighting: underlighting, color hue, and shadow contrast. To define each of them, underlighting is when the positioning of the lighting comes from beneath the subject, rather than from above. Color hue is controlling the colors of lighting used in order to produce an emotional response. Lastly, shadow contrast is using high-intensity lights and shadows to create tension in an environment or image. After choosing our lighting techniques, we determined how we would test the effectiveness of each. We decided to create a set of 3 computer-generated 3D environments and then light each environment using the 3 lighting techniques in neutral lighting, resulting in 4 lit renders per environment and a total of 12 renders. We plan to use these renders in a survey where we would ask the participants to rate the level of horror they experienced from each one. After completing the survey, we were planning to analyze the data to test our hypotheses and examine other significant factors, and then ultimately write a research paper containing our preliminary research, research process, and survey data analysis. After deciding on our testing method, we decided how we would measure our success in the project. To start, we formed 2 hypotheses to be tested and used in our measures of success. Our first hypothesis was that 80% of participant responses in the survey would correctly identify environments that used a lighting technique intended to create a sense of horror as creating a sense of horror. The second hypothesis was an average rating of 7 or higher out of 10 for a lighting technique that would identify environments intended to create a sense of horror as creating a sense of horror. After determining the methodology and hypotheses for the project, we delegated the team's tasks. Finley worked on completing the preliminary research for the paper and UV mapping, texturing, lighting, and rendering the 3D environments. Finn also edited the initial and final presentation video. Gabriel worked with editing, revising, and finalizing any documents we produced, such as formatting and revising our research paper. Gabriel also managed production, overseeing that our tasks were completed, and addressing roadblocks. I constructed the 3D environment and assisted with creation of the survey, paper, and the voiceover for the presentation. Lauren worked on UV mapping, lighting, and rendering the 3D environments, and contributed to the creation of both the final paper and presentation. Finally, Andrew constructed the 3D environments and assisted with the creation of the survey, the presentation, and the research paper, particularly in completing the statistical analysis. Now that we have introduced the project and our tasks, we will now discuss the process of our experiment. We decided to create 3 unique environments to test our techniques in: an office space, a restaurant, and an apartment. We deemed these environments to provide a good neutral atmosphere in the interest of mitigating horror effects generated from the environment itself. These environments were modeled in Revit by Andrew and I before being UV mapped, textured, and lit in Maya by Lauren and Finn with the aforementioned 4 lighting techniques of neutral, underlighting, color hue, and shadow contrast. Once the stills were completed, a survey was created using the Qualtrics software to measure participants' emotional feedback from the CG environments. Each participant was shown an image of an environment and asked to rate on a scale from 0 to 10 on the intensity of horror they felt in viewing the image. Between each environment and selection process was a prompt to continue to ensure that the previous environment did not influence emotions on the next environment. After the creation of the survey, we distributed it out amongst Purdue students for a period of 2 weeks, resulting in 101 total responses. Now that we discussed our process, we will now discuss the survey results and analysis. Starting with the demographics data, we had 90 participants respond for age and gender. The most noteworthy points in the demographics data were that our participants ranged from 18 to 24, and 52.2% of participants identified as female. These two data points show a particular skew in the demographics of our response, something which may or may not have played a role in our results. When getting into the horror ranking survey data, we decided to analyze that data using a one-way ANOVA test for statistical analysis. We took data from the results and completed 4 one-way ANOVA tests, one for the data of each environment and one for the data of each lighting technique, to determine if any variance between them was truly significant. Regarding the 3 environment ANOVA tests, only the restaurant showed a statistically significant difference. This finding shows that the environments we chose may not have been as neutral as we originally perceived them to be, or that the restaurant carried some preconceived notions of horror for some of our participants due to prior horror experience, culture, or some other factor. The final ANOVA test proved that the data from the 3 lighting techniques showed statistically significant difference versus the neutral lighting, meaning all 3 of them were more effective in the horror response they provided than the control neutral lighting. When ordering the effectiveness of each lighting technique using the data mean, they rank as follows, from most to least effective: underlighting, color hue, and then shadow contrast. To note, underlighting and color hue were very close together in their mean value. However, shadow contrast has a much smaller mean than the other two, with its mean being only slightly above the mean for the neutral lighting. Outside of the analysis via one-way ANOVA, we also investigated our data to examine whether it confirmed our original hypotheses. For the first hypothesis, if we are assuming a render effectively conveys a sense of horror at a score of 6.0 or higher, none of our environment renders ended up reaching an 80% response rate of that score or higher. For the second hypothesis, none of our renders ended up with an average rating of 7.0 or higher, with none of them even scouring above a 5. The failure to confirm the hypotheses suggests that underlighting, color hue, and shadow contrast lighting techniques, when used individually, do not create an effective sense of horror independently of other factors for renders of CG environments. With the data analyzed, we started considering how our findings could be used by professionals in the animation industry in future projects. The main contribution of our research could offer is our effectiveness in ranking horror lighting techniques. This ranking could potentially be used to help studios and lighting teams prioritize certain aspects of lighting when wanting to convey horror, be a good baseline when training new lighting artists in conveying horror, and help lighting artists focus on one aspect of lighting for conveying horror when they are looking to save time. Outside of the ranking, our research also shows that animation studios and productions that use solely underlighting, color hue, or shadow contrast independently of any other techniques or elements is not effective for conveying horror. This could prove useful if any production or studio is considering experimenting with a unique lighting style using only one lighting technique. Regarding how our findings could be used for further research, other researchers could look into whether combinations of these lighting techniques would be more effective to provide more data points in this argument, as well as adding additional horror lighting techniques for comparison. Furthermore, the study could be done with a different age range or demographic groups, like lighting artists or horror movie fanatics. To wrap up, our research study came to some significant conclusions on the effectiveness of different horror lighting techniques for CG environments. While none of our hypotheses were confirmed, the research study produced new information in the subject of digital lighting and leaves open many opportunities for further research in the future. Thank you for watching our presentation about our CGT 412 Senior Capstone Project.